Hello, good afternoon, everyone. And what we have here is a Trifilar coil axial flux hooked up to an SSG Bedini circuit from K Energy Store. Really rocks, man. This thing, it's got glorious spin time, and it's just a little disc. Um, you know, it is kind of heavy. I mean, it's cube magnets and it's 100% infill, yada yada yada. But it still gets phenomenal spin time. That's like when the power's cut. After having it on, you cut it off, and then the spin time is what you get from the residual. It's unlike anything I've seen, really. It's like 10 minutes of solid on time when it's off. Crazy. But you know, whatever it's running on when it's doing that eventually dissipates. So we've got this motor hooked up. We've got this motor hooked up axial flux. Now the magnets are facing up and down, north south with this one. Let's see which ones are right here. These are all north. North, south, north, south. Gonna put 12 volts in because I was, informed that there was a 12-volt system. 12.2. Now let me explain a little bit what I have hooked up here. I am using the third strand, the 20 gauge strand, and I'm hooking it parallel. Diggs,
He's trying to get his toy out.
could you get it for him?
I think I threw it in there.
All right. Could you get it?
Oh, you got it.
Nice, good job, Tiggs. You are the cat and a half. That's awesome. All right, so I took the 20 gauge strand and I hooked it back parallel with diodes. So the diodes are going this way back into the 18 gauge. So the negative side of the 18 gauge is hooked up, or the 20 gauge is hooked up to the 18 gauge negative side. And the positive side is hooked to the positive side. So all that energy should be going into the system parallel, and it should reduce the amount of amps drawn on the system. Normally it's like 0.5. Oh, it is 0.5. My bad. So it's using that power in a good way. Alright, I'm going to turn this other motor up. It's got to be up higher. I'm going to turn it up to like 18. Hello, hello. Hey, Caleb, what's up? So, this light over here is hooked up to this motor right here. And I got to turn it up way higher. Voltage to get the light to light up. And I think it's a different interaction between 26 and the 16, and the difference between the 18 and the 32, and the difference between radial and axial flux. But as you can see, maybe you can, that light over there in the corner is way brighter, and that's the one hooked up to this motor. I'm going to cut that power, and we're going to pay attention to this one. I don't know, man. There's a lot of Wishy-washy people on tonight. Usually the only one saying anything, no, except for Polo Jerry. Hello, man. Hello. And this is all residual spinning. Power's cut. Got you stop. Stop it. So when you make a coil, you want to do multiple strands. Got 32, got lots of 32. Got 18, 20, and 24. Different gauge wire. I like using 32 for a trigger. I'm thinking I might use 32 for a drive coil too. We can try that out. Oh man. Alright. So moving right along, can't just leave that up there. It's ridiculous. There you go. Point it at the side. Yeah, like that.
Takes his turn to get the light.
And we'll play with him over there with it.
Tiggs, go get the light.
See, another thing that I can do with this same circuit here, we'll go like this.
We'll spin it faster.
We're going to hook both lights up to the same motor this time. And the difference between, I'll show you like some really different stuff here. Like the Bedini, you don't get more than you put in on a Trifilar. Because there's that many more resistance, there's just so much more resistance and flow. It's a lot better electricity than the other way. I call it 1, 2, 3. So if you don't have a way to hook up your Bedini, SSG or whatever else you're trying to do, you just hook up your transistor directly to the circuit. missing something.
Okay.
That's it. Okay, that's it. It's a blind mistake. I didn't see it. I couldn't see it. Here we go. Turn it up to 12. And this is an 18 gauge drive. 12 and a half actually. And this is what we're getting out of the DC rectifier that's hooked up to the 20 gauge strand. We're putting in 12.5, and this is what we're getting out. Lighting 2 lights with the same circuit, which is pretty good for Bedini. It's got 2 outputs, as you can see. Can you back up from the table, dude? You were shaking it. You can't shake it when it's going that fast. Whew, man, that was scary for a second. So the power's off right now. That's the thing I find about this whole thing that's freaking awesome. It's because it likes to move. It's not really about the electricity that's coming out the other end. It's never been about that for me. It's always about spinning. I like watching things move. Nothing else matters. You going? But of course, everything else matters. It's just I don't care about it as much. It goes fast and it stays fast. It's cool. So I don't know, like 800 hertz plus for a SS, whatever, solid state, whatever it's gonna be. Should go 800 hertz or more. Easily, you know? That's fast. But then you got, 100 kilohertz fast. Man. Like I said, the power's off. That's so cool, man. Still going 1,000 RPMs. So we got all this wire over here. I want to make a new coil. Right there. I got a bunch of 32. I got 20, 18, 24. I'll make a few coils. Should be pretty awesome. I made Dynamo with these 2 pickup coils and my aluminum disc. So these just rest on the top, and the disc is a little bit elevated above. It's all 6 inches, so when the bottom disc starts moving, the magnets create eddy currents in the aluminum disc and are picked up by these 2 coils, which are hooked in series. So the voltage, you get a little bit. You get a little bit, like 5 volts. And it's all eddy current. It's all eddy current. You would say, you'd argue that these magnets are breaching the aluminum and causing that little bit of energy. But it isn't. It isn't. Not the way I set it up. Because if it was that, then it would continue to increase when the speed increased, correct? Well, and I do know that when you move these coils closer to the edge, like hanging over, then the voltage goes way up. So if you have them centered on the disc, which is right here, and I have this magnetic clamp, but you put this on the top, elevated enough so that when it turns, it doesn't spin very much, but just so, like, if you don't anchor it, it will spin. Get it right there. Maybe a little more like toughness on the spin, a little bit more spin to it, and anchor it down. And then all that spinning will generate eddy currents in the aluminum disc, and you pick them up with something small, so thinner gauge. It's really neat. I guess some people will call that free, but I don't know, man. I'm just struggling with that concept of the freedom. I know that it's energy you wouldn't get if you didn't hook that up. I know that. And I like that idea. That you gotta harness that energy that's there. But like saying that it isn't free is not saying that it isn't there. Because I know it's there. It's just, there are things that we don't know about yet that fit into the puzzle. Because the puzzle's nowhere near done. You know what I'm saying? It's not finito. They did not finish the puzzle in the 1800s. It's just not the truth. Still spinning. All right. Got these nice new caps. 400 volt, 1000 micro. These things, when they pop, they pop. When you empty them. Very big spark. Got these. Wow, that one feels a little flat there. 63 volt, 4700 micro. And they work very well for this motor. We're getting to that point where the spinning isn't going to really count for much. We're at 0.17 volts on the backlash. It'll continue to spin, but I don't think it'll spin for very much. All right. So there are like several things that I can do with this third strand. Right now it's hooked up to the light. I can hook it up to itself with a diode. One of these doohickeys. Right, this diode will go back that way. So this is the front, this is the back. It's going to take the back and it's going to send it back into the front of its own strand. And since it's not the drive strand, it should be able to do it without a tremendous load, but it's going to put a load on it. But it's going to drop our amp draw by about 400 milliamps. And this is a north-south arrangement. I don't know if it's really good for Bedini SSG, but see, now we're not getting any light action with it hooked up this way. And it's not hooked up directly to the drive, so I'm thinking that there's definitely some transformer thing going on right now. But we're only drawing 100 milliamps. Now this will get going nowhere as fast as it does the other way, without it hooked into itself and just like hooked up to a flow. Like the light is part of the circuit now, and then it will flow through the light. We need a load like that it will flow through. That's not a cap, man. We're not trying to like blow anything up. We're you hook this up to a battery, the battery's going to be faulty. I'm not saying that the Bedini circuit can't hook up to a battery. I'm saying you hook this up to a battery, it's going to blow the battery up. It's going to not work anymore. That's what I mean by that. I have two batteries over there that are dead in the water because I hooked it up to a circuit that was too strong for it. And that's like having an 18 gauge when the typical build is 20 gauge. It's just too much. And I've tried, I hooked the batteries up and they're like down to 500 millivolts and they will not charge with this circuit. So I'm kind of bummed about that. I might get a store-bought charger, but I don't think that it's going to work. As a matter of fact, I did already do that, and it does not work. These batteries are now useless. That's a lot of money. So I got my lithium-ion batteries, and I'm only using those as a power source. I don't like the charging of the batteries hasn't been good to me at all. So I'm not even worried about that. I love watching things spin. That's my objective, to make it spin fast, and make it keep spinning when you turn the power off. Now that is my new objective. And will it continue to spin forever? That's not my objective. I would state that in the objectives if that was one of my objectives. It's not. I don't care about that. And I'm always like, what's the big deal? What's the big deal, man? So this thing will keep spinning. Well, I mean, the spinning part is awesome. As long as it, like, there's something to captivate you. And lighting lights and spinning and doing things like that is very captivating. You put the light on so you can see what's going on. And to get that visual is captivating. If it's spinning and it's spinning fast, and it's not even have to spin fast, but if it, like, is spinning and then it continues to spin at a respectable rate after you turn the power off, that's great. Like 10 minutes, this thing will go. I leave it on the right speed, 12 volts. Oh yeah, no. I'm gonna show you the difference between this way do, however, want to keep this kind of connected. I don't want to leave it hanging there when I turn it on, because it's not like it isn't hanging there now, but there's definitely a load on it this way. Alright, so huh. That's weird. Now it's like not letting me go back the other way. It's not letting me run with the light on. I think he did say that I have to stop it and start it again once I switch stuff. So this should turn the lights on. Might as well hook these up again, because it should work. If it doesn't work, I don't know. No, something's not right. There it goes. We're at 500 milliamps now instead of 600. It's noisy though, that's the thing, and it's axial flux, and I think there's something moving in there. It's not very good. Welcome, welcome. Had to change up the sound there. I think I was getting some interference. What's up, Mike? And I got the Distinct impression that somebody's been talking smack. And I think it might have been me. So my bad. Not to you, but just in general. Yeah, I think it's funny what it's actually done for me in a bad way. It's freaking hilarious. What's up, brother man? What's up, kids? Look at that thing go, man. Guess how many volts I put in there? Axial flux has got the wind for the spin, you know? This coil is just powerful. I don't know any other way to explain it. Alright, so I'll put some power into it real quick. I'm going to time this one. That's 12 volts for a 12 volt system. And the power's cut. Yeah. Hey, kids. Come here. Come here, little baby. Kids. He's like, nah, I don't think so. Thank you all for chilling, having a good time and everything. I knew that when it started off with the government's coming for me, that it wasn't going to be a great night, but maybe it will be. It'll end up being good. So 32, 24, 32. It sounds like measurements, man. Measurements. 20. Oh, and it's got an end sticking out the back. We could just set this all up. This is great. Just right there, that's a done coil. That's great, man. It's already done. And so is the 18 gauge the same way. It's got the beginning sticking out the end here. Or maybe that is the beginning. Yeah, maybe not. Oh, no, okay, it's just the one end. That would have been something, you know? That's almost a perfect size, too. Of course, I'd have to wrap it myself, but it would have been neat. Alright, how many volts do you think I put in here? How volts you think are in there right now? There's been 0 volts in for 5 minutes now. That's awesome. This must be standard Bedini axial flux. You know, like this happens normally. Because that's not, I mean, just any other setup doesn't make it spin this long. It doesn't happen. We're gonna light this one up, and I'm gonna prove it. All right. So that's kind of simmering down, right? Got that light lighting up. The little one's still going from before, right? Ceramic bearings in here. $18 volts in. Running on the same SSG circuit. I'll show you just for good measure. Right there on the corner is an SSG. Right there is another one. That one is hooked up to this one. And so forth. Now I'm saying that's axial flux because the radio is going to stop before this one ends up stopping. That's awesome, man. I know if I was supposed to know that, I wasn't paying attention. Now I'm paying attention. I think it's pretty cool. Okay. Yay. Now we're running out of steam, but you can tell this one's coming to a slow, this one's stopping already. And this one is just now starting to really stop. That's great, man. That took how many minutes to demonstrate? Like 2 minutes altogether at the end of this spin. Wow. Let's see how this is set up real quick. Let's get a look. all we have is the coil, a flange to raise this bearing to an appropriate level for the rotor to rest on it. Now there's not, well, I mean, it's not frictional per se. There's a little friction there. But see, this is a flanged bearing. The one on the bottom is not flanged, so it rests directly on that bearing. So the friction really comes between the bearing down there and the flange. It's not between the bearing and the rotor. And then north-south orientation with the magnets facing up and down. And I'm thinking like, wow, it's just so awesome that it moves. Moves really smoothly. Please like, share, subscribe. You know, join in the fun. I do this quite often. I haven't done it as often lately because I've been doing other things. I've been bored. I've been playing games again. But this is good, man. This is an old coil. 18 gauge, 20 gauge, and 32 gauge. Currently the 18 gauge is not hooked up. I mean the 20 gauge is not hooked up. It's right here. I don't want to touch that though. There's quite a bit of rattling going on, but it's not bothering me that much. Here, let's find out what the deal is. That is awesome. And see what's cool about it is that you get all that oomph and the amps don't go too high. That's, I think, what all the circuitry here is about, is kind of putting it into a zone that it works and functions best at. What I mean is the flow, like from power supply to ground, from positive to negative of the power supply. You know, you gotta like control it, all that energy, focus it. And the circuit, I believe, does a good job of doing that because it functions pretty good at like 12.5 volts. Like it's supposed to. Notice I don't have any other coils hooked up right now. I'm just playing with the 20 gauge strand in the Trifilar coil. I love it. I know it's loud. I apologize for how loud that is, but it's axial flux. And there's something loose. I believe one of the magnets is kind of loose. Should be alright though. Oh man, so I don't know, I'll probably do another live tomorrow in the morning, more in the morning, you know, just kind of wake up because there's other people in the niche, so to say, that do it at night, and I don't want to interfere with them and then them interfere with me. I think we can work together to both do what we want to do in a timely and orderly fashion. So this is going to be a shorter one today. The coil that I want to build is either going to be a trifilar or a multifilar, like 4 or more. Now what I want to do is I want to do an 18 gauge strand in it, a 20 gauge strand in it, and then a 24 gauge strand in it. And then for each one of those strands, I want to have a 32 gauge trigger strand for each one. Simple enough, right? And I think we're going to have a much better deal running that system parallel than we're going to have running one with one trigger strand in it. I just have a feeling. And if I'm wrong, then I hook all those trigger strands into one series trigger. But that's going to defeat the purpose. So we'll probably have to hook all the 18, 20, and 24 into a series as well. But I do know that having the separate trigger strands is going to be more of a help than a hindrance. Yeah, so like all the conductive materials out there that we had no idea conducted. I mean, there's lots of really awesome shows going on just everywhere. Mike does. He's got some awesome schematics, and he likes talking about the alternative energy. I like calling it alternative energy and exponential energy gain, things like that. Because you are getting, there's no doubt you're getting bigger numbers. But like I said, if you put the right resistance and you kind of funnel it and focus it, those big numbers aren't going to end up being as big as they are on your meter, because you got to put the resistance in there, and just poking a light up to it cuts it down to like 78 volts flat. The other energy type, and it's like standard, like 78 is as high as it will go, but your light will be on. So yeah, I think it's going to be a trifilar coil, tri-drive coil. That's what it's going to be. 1832, 2032, and 2432. Boom, boom, boom. And it's all going to be in the same coil. So what is that, a 3-phase motor in one coil? I mean, honestly, I could hook each one of those strands up to 2 additional coils or 3 additional coils on. I could do that. I could extend those drives. They don't just have to end in the coil. They can be in series with other things. But I don't know, because they're all going to hit at the same time. That's the issue. But also what I was thinking is hooking this up to the signal generator, having the 20 gauge strand on the second phase, channel 2, and have it offset by 5 degrees, that. So you get a slight staggering effect, but they're still kind of overlapping. You know, make it signify motion. Like if it was moving, this is what it would look like, and then make that happen, and it'll think it's moving. It's, you know, if it had a thought process to begin with, it would think that it's moving at that point. I don't know. But it's usually about tricking what's inside the bubble into, you know, creating that environment inside the bubble that is stable. Let's just put it that way. It's stable. So like the Starship Enterprise would be stable, and then you just move the space around it. You get what I'm saying? And warp drive right there. Space is space is the thing that you move. And yeah, it's basically the same concept. Having that bubble, that contained environment, that created atmosphere that's really there. I mean, it's not like it's fake. It's like it's necessary. It's a lot to think about, especially when you don't read about it. You just think about it. And a lot of that stuff can be wrong. But in my case, I have had good luck in my understandings, and I think I get it. Because I've been like thinking about how to create that bubble for a long time. And I didn't know what to call it or how to build it or how to make it, anything like that. But I know that that is the way for a lot of things to happen. You know, warp travel, time travel, you know, space exploration on a level that we haven't, you know, begun to think about because we haven't like had the tech or paid too much attention to it until like recently. And I mean, everything that came before, you know, the huge, you know, cataclysm 13,000 years ago, anything that came before that doesn't matter right now. We've got the information. We can find stuff that matters. It's not that it doesn't matter. That's a wrong way of putting it. It matters. I'm just saying that it's not. It is where we are going to find the next step. And I hope we find it soon, you know, because that meteor shower thing is supposed to happen twice per cycle and about equivocative distance apart from one another. So we're coming up on the next one pretty soon. I would, you know, put a lot of effort into meteorite defense. I would put a lot of effort into, you know, trying to make sure that we didn't fall into a position like that again, where everything's washed away, and we're, you know, we'd be lucky if anybody found anything of our existence. It's I don't know, like it's not too far-fetched of an idea that if the meteors are in a belt that goes like, you know, like this, and then the Earth is in a rotation like this, that twice in the cycle, it's going to pass through that belt. I've been thinking about that a lot too, and that is more than likely going to happen. I know we hear about all these close calls and everything, but this is real. This is scientifically proven that asteroids, meteorites devastatingly hit all over the planet. Like it spun a day in this field of asteroids and it got destroyed. Basically, the entire surface was gone. Covered in water, floods, pus, pumice, all that stuff, man. Just everywhere. It's like, how do you know that? Well, I don't. It's not like I witnessed it. But in order to know something, I found, like, strangely enough, you don't have to witness it to know what's going to happen. Or I don't. You just use the worst parts of your imagination, you'll figure it out. Yeah, but I don't know. I don't know. I mean, it really shocked me, like, to my core, hearing that it would happen again. And it makes total sense if you look at it, if you think about it as one is going in a loop like this, one's going like this, and then the Earth is going like this, and the sun's somewhere in the middle. But those asteroids have their own, what do we orbit around the sun? Maybe around other things as well. I mean, the asteroids, that's how the next planet's going to get made. I mean, I don't think we're done fully formulating the universe either. We're not done yet. It's not over yet. There's gonna be another planet. Maybe more than one more planet. And I mean, I'm not worried about it, man. It's gonna be 1 billion years from now. So what? And don't be worried about it. And don't be worried about it. I'm not worried about it. It intrigues me. I like talking about it. What can I do with this? I was thinking about, I don't want to hook it up to a transistor because it's already got like 8 volts going through it when I turn the other one on, the 18 gauge one. And then the 20 gauge has already got 8 volts pumping through it, so putting a transistor on there, probably not good. Okay, so and I mean, we've proven that axial flux spins way better than the radial. I mean, the radial has ceramic bearings in it, and it still didn't spin anywhere near as good. All right, so let's see. There we go. Yay! So that's it. I'm gonna craft a bobbin, or I might just use like a red, one of the 1 pound bobbins, and then I'm gonna make a 6 filer, one with 18, one with 20, and with 24 for drive, and then 332 parallel strands for triggers. That'll be so, if I am correct, that'll be awesome. Like beyond belief. I'm really excited about making this, so I think I might get started here in a couple minutes. Now all I gotta do is make the trigger strand enough length to trigger the drive. That's all I really gotta do. That's the ones that gotta equal each other, is the length, or how much voltage is generated at the base. The other ones are all gonna be the same length, but of course they're gonna have different responses, different ampage, but it's all gonna sort itself out. It's going to sort itself out, at least to the point where it'll function, I hope. And then I can always hook them up individually, like in one, I can hook up the 18, I can hook up the 20, I can hook up the 24, I can hook them all up in series, I can hook up one in series and one in parallel, I can do a lot of different things. As a matter of fact, I can hook them all, I can use, you know, well, actually, no. Then I'm saying I could use 32 for a drive as well, but that would be not accurate. I mean, I could, but then each one of the primary drives won't have their own strand, trigger strand. I'm trying to make it as simply as I can, nothing complicated where I'm twisting stuff and bending it back around itself and all this crap. I'm just going to wind this one. I do want to learn that crap though. I really do. And I want to take my time on one of them and like make it go both ways and back and forth, and you know, the light, if you turn it past it on this way, the light will light up over here. You turn it over this way, it'll light up over here. You know, all the crazy stuff you got to do to make that happen. I want to do that. I want to learn how to do that. And I know there's lots of, you know, stuff online on YouTube that will teach me how to do this, and I'm going to look into it. It's still going. Nothing outlasts Papa Bale's rotor. But like if I wanted to be really creative, I could try to make each one of these primary drive strands equal the same amount of ohms. And wrap just that amount of that drive in the coil. And then there'll be say 5 ohms. I don't know how much 24 gauges in 5 has, you know, is for 5 ohms, but it's not a lot. About 5 ohms of 20 gauge is going to be a lot more. I don't even know if I have 5 ohms of 18. Probably not. But that's just an example. You can make the ohms match. I tried doing that, you know, earlier with a different setup. Where are those coils? Right here. Actually, I did the length of them. These are 1,500 turns of 32 gauge a piece. And then there's a soft iron core that fits right in the center of these. And then if you put them together, that's 6,000 turns, and there's 4 iron cores in there. 6,000 turns with 4 iron cores is like awesome. See, my new bobbin is going to be about this big, and this was going to fit right in the center. I'm going to make it this size. So we're going to have an iron core for the drive finally. Whether it needs it or not, I don't know yet. I think this is going to be a straight parallel. I'm not going to do blitz this time. It's going to be straight wrap. And well, bam, it's coming to a stop now. See, that is glorious, like, rotation. If anybody watched that whole thing, man, that is unbelievable in my mind. That is great bearings. That is will to spin. That is a will to spin. Now, there is another coil that I wanted to make. I'm going to make it out of 24 gauge. And it's going to start right here. It's going to wrap around. And it's going to be a serpentine coil that's in the shape of a C instead of a circle. We'll see if that works. I print off a former that's a square. with you know, a zigzag formation that I can put a Litz wire on. We'll see if it generates any amps or volts. I'm willing to toss up in the air. I don't know if it's gonna happen or not. Well, I'll do it, but I don't know if it's gonna generate anything. It should, based on, you know, design. I read about it. The more you have it go vertical when you're going on your zigzag, the more energy you're gonna get. Especially if it's like a square. Your magnet is a square, the more vertical you get, the better. All right. Huh. I heard the door. Let me think here. Yeah, there's not much to it right now. I'm gonna make another coil. Feel like that's what I need to do. Awesome, man. I love this. Especially the two lights on the same Bedini circuit, man. That's great. They're not in series or anything. Yeah, let's get some. There we go. Yeah. Turn on the right. Thanks. So this was going about 2,000 RPMs. Not the fastest thing in the world, but I mean, it doesn't need to go that fast, obviously, for it to continue to want to run. Still at about 2,000. All right, now the ultimate test here. I'm gonna do it right now. Between axial and radial. I'm gonna do the same. This will probably wrap it up. When you're on the top and the bottom, it slows down fast. I'm sorry, but did he do something wrong? So now I'm going to remove this, put this, it's going to go all the way down now. which is going to stabilize it even further because the center of gravity is going to be low. I may have to switch the magnets, but we'll see. Have them facing outward, but we're gonna see. Right. Yep, we're gonna have to switch those. So I'm keeping it north-south, but I am changing it to radial. Yay, all right. Didn't take too long. Now we're gonna see the difference in the aftermath, kind of. Now I have a feeling that this is going to get up going a lot faster, but it's going to slow down faster too. You will see though. Power cut. We're about a 5-volt backlash. What you looking at, Tig? Kind of find out that unless your maglev is perfect and really not touching the rotor, and if your shaft is touching the rotor and the maglev is touching the shaft, your maglev is touching the rotor. Because the shaft becomes an extension of the rotor at that point. That is moving really well. That was great. My daughter is practicing her band instrument, which is a clarinet. Alright, so we want to put it like right in there. That off, spin that around. Now, I don't know if this way will generate many eddy currents. But since they're facing outwards, see, in this, it just solidifies everything. You saw that just clamp down there, right? Okay, so that's not going to spin. Hold on, let me make sure these are all in there. Oh, I remember now. When you're using this maglev disc system, you want to have all your magnets facing a certain way. We're going to do them all south. Alright, now let's see if we get this right here. Now I'm going to flip it over. Let's feel. I don't know, so let's flip it over. Oh yeah. That's in there really good. Tiggs. Do you mind, young sir? Here we go. So now I think they're all facing south out, and that they're in there good now because of where the maglev is on there. So it's a clamp for this one. It's a stabilizer for this one. That maglev washer system is really good. Excuse me, sir. You get down? Thanks. All right. Should get a low reading DC. Can you get down? Thanks. About to turn this on, baby, and you don't even get scared. There we go, eddy currents. There we go. That's interesting. I think it needs to be lowered a little bit. But yeah, I'm gonna take it easy for now. Thanks all for hanging out. Really appreciate it. Peace out. Have a great night. Talk to you all tomorrow. Bye now.